Hey everybody, I'm Adam Kolodny, and back in high school I was a math tutor, and I noticed a lot of people were having a lot of trouble, so I made this video of tips on how to solve any math problem to cover the most frequently occurring ones. Alright, so, contrary to popular belief, math is not that hard. However, it does get complicated after a while. Take, for example, these problems I'm putting up for you. Now, you're probably all just figuring them out, solving them in your head just by looking at them. Now, let's get into something a bit more advanced, like the square root of 25 or the cubed root of 125. You may have to use a calculator, but it's still fairly easy. Now, this problem is not so easy. Now, there are some steps that you're going to need to do in order to solve this problem. Now, the first step is to take a deep breath, or curse if you're old enough. The second step is to swear your soul to the Dark Lord. Now, the third step is to break it up into parts. And when breaking it up into parts, you need to know which order to do this. Fortunately, there's something called the order of operations, or PEMDAS. Now, so in this problem, when following PEMDAS, the first thing you're going to do is the stuff inside the parentheses. Now, since there's a bunch of variables inside the parentheses, first thing you're going to have to do is look for that y. Now, there's only something to do in this particular case because that y is to the power of a negative exponent. When something's to the power of a negative exponent, it has to be put on the opposite side of the fraction that it's already on. So, and if it's something that's just standing alone, like in this problem down here, you would just simply put a 1 on top of it. Now, so just put that y onto the bottom side of the fraction, and you've done everything that you can inside those parentheses. So the next step is to do the exponent as the e in PEMDAS. So you just multiply everything to the power of 3. So you get 27, x to the third, y to the 12th, or no, y to the 9th, I'm sorry, and z to the 12th. And then that is the most simplest form you can put that problem in. Now we might be saying, wait, can I do anything with those exponents? If you had an x on the bottom, or a z or y still on the top, then in theory you would be able to. However, this is the simplest form of that problem. Alright, is it okay? You guys got everything okay? That's great. Now, if there's one thing that me and Bart Simpson have in common, it's that nobody can tell where our hair starts and our skin ends. Now, if there's a second thing, it's that we both hate fractions. So let's take this second problem right here. It's got fractions and exponents that are also fractions. Fortunately for us, that bottom exponent is negative, so we can just put that x up onto the top so that we have 7x to the power of 1/6 and x to the power of 1/5. Now what we have to do now is to find the lowest common denominator, which in this case will be 30. Now you might be asking yourself, wait, how do we get from 6 and 5 to 30? I thought we weren't just allowed to randomly do whatever we wanted. Well, you're right. Under normal circumstances, we're not. However, what we're doing here is multiplying both equations by 1. And so by multiplying both equations by 1, and since 1 is essentially equal to all numbers during multiplication, we can get it to 5 over 5 and 6 over 6. When multiplying fractions, you don't need to do the lowest common denominator thing. And in case I forgot to mention it before, when you're multiplying the same base, you add the exponents that are on top of them, and you can't add fractions with different bases. So we get 5 over 30 plus 6 over 30. Since they have the same base, you can add them together to 11 over 30. So you get, so your final answer is 7x to the power of 11 over 30. Now when you see fractions over exponents, it's basically you're both finding the root and then finding the exponent for the top. The bottom number on the fraction, the denominator, is the root. It would be the number outside of the radical. And then, you just got the 11 there for the x. Alright, so that is a good place to end the exponent things. However, let's talk about conjugates, or most specifically, radical signs on the bottom of a fraction. Now, when you see it like so, then you don't really have much problem. You just gotta multiply it by 1 again, and then put it back on the top. However, when you see it like this, then you have to multiply by the conjugate. Well, first you multiply it by 1, and then you create the conjugate, which is basically the sign in the middle is swapped, like so. And so you get 5x, or a square root of 5 plus the square root of 2 times the entire equation. The bottom's 5 becomes 5 minus 2 because you're squaring the square root, so that just cancels right on out. You get a normal denominator, which equals 3, then you get this top number, which can't be simplified anymore, so you can just be done with the whole thing. And now let's talk about FOIL. It's like making cookie dough. If you just multiply everything by the corresponding, that's in like the same place, then you're not gonna get anything good or right. However, if you multiply everything together, then you get the delicious cookie dough. Now, the FOIL system was created by William FOIL, whose brother Bill FOIL created tinfoil. But it stands for first, outer, inner, last, and that's the order of operations for multiplying two things in a parentheses, or something in a parentheses with an exponent on top of it. And remember, when something with an exponent on top of it, it's not supposed to just square both numbers inside. You gotta FOIL that too. So that should be pretty easy to explain if you're trying to like solve for a variable inside of a FOIL. You got to remember that one is going to be positive and one is going to be negative. In order to find out which one is accurate for the positive or negative, just throw it back inside the equation, and if it works, then that is the correct number. In order to solve, you got to isolate the two variables, and it'll look like so. And so, back when I was tutoring people in geometry, it seemed like most people were having problems with the side angle side postulate, angle side postulate, and angle side angle, which is very simple to use. And in fact, the answer to how to use these is going to apply to all other math problems you're quite possibly going to ever do. And that is, use what is given. Like, for example, in this triangle, you get two sides and an angle. However, fortunately, that angle is within the two sides. Yeah, and so that means, though, this would be similar to a different triangle that happens to have those two side angle sides, and so they would have the same area. That's really all you need to know to use that. In the end, the most important thing to remember about all these fractions and variables is that they all equal a value. It's like this conspiracy board. If you don't see Girl Scouts are responsible for crop circles, you're not looking hard enough. Alright everybody, I really hope you enjoyed today's video. If you learned something from it or think it helped you, make sure you leave a like. And if you want me to go over something else next week, tell me in the comment section below. I will see you all next week, and I hope you have a great week.